Now, we have been talking about intrinsic semiconductors. Those are the purest form of semiconductors without any impurity in them. But there is another type of semiconductor, which is extrinsic semiconductor, it is called. Now, this extrinsic semiconductor has the characteristic such that their property can be significantly altered by addition of certain impurity atoms into the pure semiconductor material. So, but what type of impurities will be added to the purest semiconductor to make an extrinsic semiconductor are defined. Like we can add pentavalent impurity materials like antimony, arsenic and phosphorus, which are group 5 elements and have 5 electrons in the outermost orbit. Or we can add trivalent materials like boron, gallium and indium, which are group 3 materials and have 3 electrons in their outermost orbit. And the standard norm of adding is that they are added 1 part in 10 millions. That is, in 10 million of atoms of intrinsic semiconductor, you add an impurity atom, 1 impurity atom. Now, how this addition of these impurities totally change the electrical properties of the intrinsic semiconductor material, that we will be discussing. So, when certain impurity atoms like antimony or boron are added to a pure semiconductor material, we get an extrinsic semiconductor. And this process of adding certain impurity atoms like antimony or boron into pure semiconductor like silicon is called a doping process. As a result of this doping, we get extrinsic semiconductor, either N-type or P-type. That is, you can get N-type extrinsic semiconductor if you add pentavalent impurity material like antimony, phosphorus into a pure semiconductor like germanium or silicon. Or you can have P-type extrinsic semiconductor when you add trivalent impurity material like boron or indium into a pure germanium or silicon semiconductor. But what happens when you add an impurity atom to a pure semiconductor? So let us take, for example, an N-type semiconductor, how it is formed. Now, as N-type semiconductor means we have to add pentavalent impurity material. So let us take the example of adding antimony, which is a pentavalent impurity material, which is a group 5 material having 5 electrons in the outermost orbit, to a silicon semiconductor. Now, this silicon atom has 4 electrons in the outermost orbit. So these are silicon outermost orbit electrons. And now, as we have added 1 antimony atom which has 5 electrons in the outermost orbit, so it will be sharing these electrons with the silicon atoms. Like these covalent bonds will be completed. 4 and 4, 8 electrons are there, so these covalent bonds will be completed. But then 1 electron is in excess, that is, it is extra. So this 5th electron is donated by this antimony atom. Now, which is this 5th electron is free. It can take part in conduction easily. That is why it is donating as 1 electron. So it is excess of 1 electron which is negatively charged. So this is called N-type semiconductor. What happens when we add P-type semiconductor? So we have seen how N-type semiconductor is formed by adding pentavalent impurity material to intrinsic semiconductor like germanium or silicon. Now let us see how P-type semiconductor is formed from pure semiconductor like germanium or silicon by adding trivalent impurity material like boron or indium. Now let us add boron impurity, which is a group 3 material having 3 electrons in the outermost orbit, to a silicon semiconductor. Now this boron has 3 electrons in the outermost orbit, so it will be completing its covalent bond with a neighboring silicon atom having shared these 2 electrons as is seen here. So these two electrons will form a covalent bond. So in this process 3 covalent bonds are now completed. But what about the other covalent bond? This covalent bond is now devoid, or it is short of 1 electron to complete its covalent bond. So this shortage of 1 electron means it is having a less negative charge. So this less negative charge or a positive charge is there in this covalent bond. So this is called a hole. Hole means it is basically devoid of 1 electron. So there is a hole formed here in this covalent bond, and this hole is a positively charged particle. So this p-type semiconductor basically is formed in this way, which will be having holes as charge carriers. So now if we consider again the n-type material, we have seen that in n-type material, which is an extrinsic semiconductor, it has donated 1 electron. So as it has donated 1 electron, the atom of this extrinsic semiconductor is now having 1 positive charge, which is called an ion. So one atom of this extrinsic semiconductor, when it donated 1 electron, it has become ion having 1 positive charge, which is shown here. So the donor ions are having 1 positive charge, and there will be electrons which are in abundance in the n-type material. These are called majority carriers. So in an n-type material, the majority carriers are electrons, but there will also be in less numbers minority carriers, which are holes. These holes will be from this intrinsic material that is coming. So if n-type material is considered, altogether we will be seeing majority carriers as electrons, minority carriers as holes, and immobile ions which are positively charged are donor ions. This is the structure of an n-type material. Similarly, if we consider a p-type material, since p-type material has acceptor ions which are formed because if we consider the p-type material, then we have seen that there is a hole, and as it is devoid of an electron, it will be always trying to get an electron from the neighborhood atoms. So the electron from the neighborhood atom will come and fill up this hole, and as a result this boron atom will be now, it will be negatively charged. So it is accepting 1 electron, so it will be negatively charged. So that means in a p-type material, the atom of the impurity will be an acceptor ion having a negative charge, and there will be holes which are positively charged as majority carriers, and also a very less in numbers, although there will be presence of minority carriers which are electrons which are coming from the intrinsic semiconductor. So this is p-type material